Hello everyone, my name is Shambhavi. Hope you all are doing well. So fine. Now today we are going to discuss regarding the F ratio or the F statistics, that what are these two terms and what do they actually mean out. Okay. So I would just put on the heading right here. The heading is F ratio. It's F ratio or it's F statistic. It's F ratio or it's basically the F statistic. Okay, now let me just come down right here. Let me remove out this particular one from this particular one. Great. Now what we'll be doing out here is that let's go ahead, proceed on, and let's see that basically what are the things that come under the F ratio or basically the F statistics. Okay, great. First of all, I will just let you know the formula. That's it's F is equal to ms between or divided by ms within. Fine. So F is equal to ms between divided by ms within, right? Now, I would just get down and get out some space for me of writing. So here we go, that if ms between and ms within, if ms between and ms within estimate the same value, estimate out the same value. Now, when can both of these have and estimate out the same value? When can this be done actually? So, it can be done in that particular case when we just, I could say that when we just say about that in that case when we believe that H naught is true, H naught basically means my null hypothesis. So, whenever my null hypothesis is true, so in that case I could say about the ms between and the ms within estimate out the same value, right? Then in that case what happens? So I could add on then the F ratio. Then the F ratio should be approximately. So in that particular case, the F ratio should be approximately equal to 1. Fine. So whenever the ms between and ms within estimate out the same value, so in that case the F ratio should be approximately equal to 1. Now, mostly just sampling errors, just sampling errors would contribute. Let me just go down here for a short time. Fine. So if the ms between and the ms within estimate the same value, then the F ratio should be approximately equal to 1. Mostly it is the sampling errors would contribute out. Okay, let me start writing out. Mostly these values will contribute the, and now basically here the variations contribute to the variations away from 1. Away from 1. Okay. Just sampling errors would contribute to the variations away from 1. Okay. Now, in that case, basically, now after that we have that when basically turns out to be the ms between. So it consists out of a population variance plus a variance that is produced from the differences which is between the samples. I would again repeat it. Let me write that only. So we have ms with ms between, right? So ms between consists of the population variance plus a variance plus a variance produced by plus a variance produced from the difference produced from the differences produced from the differences between the samples. Okay, this is what actually I was telling you in regard of the ms between. Now what if I talk about the ms within? So ms, and here goes within. So ms within. So ms within is an estimate. It is an ms within is an estimate. Oh, okay. Let me remove it out. So ms within is an estimate of the population variance of the population variance. Okay, it is an estimate of the population variance. So since the variances are always positive, since the variances are always positive, since the variances are always positive, so if the null hypothesis, is false. Okay. See, ms within is an estimate of the population variance, right? So since the variances are always positive, if the null hypothesis is false, okay, so in that case ms between, what will I do? So in that case ms between will generally be larger. Let me come down. So in that case the ms between will generally be, here goes, will generally be larger than ms within. Okay, then in that case the f ratio that will be coming will as well be larger than 1. Okay, the f ratio that will be coming, it will as well be larger than 1 in that particular case. Fine. Now next we have basically if the population effect size is the most, okay, in that it is not unlikely. So we see that ms within will be larger in a given particular sample. Okay, if basically we are having some larger value or anything like that, so in that case we just take it out that the value for the ms within will be larger in a given sample. Okay. Now what is the condition when these above calculations were done? Okay, so the above conditions were done with a group of different sizes. So different sizes were taken. What are the above calculations? So I have written out here. All these were performed. So basically, if the group size which has been taken, if that would be the same, okay, if the groups are basically of the same size, then the calculations basically simplify, right? And the f ratio could be simply written out as, now in that particular case we have one more way to write out the f ratio when basically all the groups are having the same sample size. I would write that out. So I would mention that when groups have let me remove out, when groups have same same sample size, so in that case we could say that for f ratio, then in that case the f ratio formula MULA formula. So when groups have same sample size, then the f ratio formula is, let me get out some space for me. So in that case the formula is capital F is equal to n into S. In the downside we have x bar whole square divided by s square, and here it's the pooled. Okay, so this is the formula which we follow when the groups are having the same sample size. Okay, now what are these parameters? So n is basically the sample size. N is the sample size first of all. Okay, then secondly we have df numerator. What is that? That is equal to k minus 1. Then we have df denominator. So df, and here goes the denominator. Fine. What is that? That is equal to n minus of k. Fine. I would come down. Now next we are having s square pooled. S square pooled. Okay. That is equal to the mean. That is equal to the mean of the sample variance. Mean of the sample variance. Variance. Fine. Mean of the same sample. That's only the pooled variance which I have written above in the formula. Okay. Okay, that's not the variable. It's variance. Right. This right here. The mean of the sample variance, that's called as the pooled variance. And next, what I'm having here, Sx bar squared is equal to the variance of the sample means. The variance of the sample means. And here goes the means, right? So yeah, let me go above. Right, so this is about the F ratio or the F statistic. The formula is F is equal to MS between divided by MS within. Now, if basically MS between and MS within estimate out the same value, then in that case the F ratio should be approximately equal to 1. Right? Mostly the sampling errors would contribute to the variations away from 1. So MS between consists of the population variance plus a variance produced from the difference between the samples. Right? Next, MS within is an estimate of the population variance. Since variances are always positive, so if the null hypothesis is false, so in that case MS between will generally be larger than MS within. When the groups have same sample size, the F ratio formula is F is equal to N into Sx bar squared divided by S squared pooled. What is N? N is the sample size. What's the DF numerator? That's K minus 1. DF denominator is equal to N minus K. Then we have S squared pooled. So that is equal to the mean of the sample variance. That is the pooled variance. And S bar squared. So X bar X squared are the variance of the sample means. Right. So hope I made this particular thing very much clear to you regarding the F ratio and right here. And the F statistics. Now we have some more things to look upon these things only that I'll be covering in the next video. So this is all for this video. Till then, thank you and take care.